Right, you can hear me okay. Right, today I'm talking about a very introduction to software-defined radio. I'm going to start off by talking about why on earth do we need a software-defined radio? What is a software-defined radio? And I'll talk a little bit about the products that our company make. And then I'll give three example applications of software-defined radio, including digital television transmission and reception, Gsm Base Station, and a 4G system being deployed at the University of Guildford and also being deployed in the Scottish Highlands somewhere. So back in the 1940s, life was frightfully simple. You had three modulation schemes. You had Morse code, you had the BBC transmitting AM modulation for entertainment, and there was a little bit of frequency shift keying going on. And then kind of in the 1950s, it started getting complicated. Someone invented FM, and obviously the transistor radio started taking off. And then about 1991, an explosion of radio standards took place on the back of the 2G GSM system that was released. So broadly, you can divide the different radio standards into four different categories. There's the various data radio standards, which you're probably very familiar with, such as Wi-Fi, Bluetooth, LoRa, and so on. There's the mobile standards, such as 2G, 3G, and 4G. And then there's the entertainment-based systems, such as digital television, digital satellite, and their second generations, DAB and DAB2, and obviously good old-fashioned FM and AM. And then you have the navigation-based radio systems, such as GPS and Galileo, and the Japanese and Chinese versions. So if you like, this is an engineer's view of software-defined, of the radio environment. So as a designer, you're normally asked not only to produce one of these, but you have to produce some combination of these for modern day products. So for example, your 4G phone will support 3G, 2G, probably GPS and so on. So the cost of actually developing a specific piece of silicon for this suddenly becomes horrendously expensive. So software becomes a very much more affordable route to generate these. So let's flip it on its head now and look at it from the consumer's point of view. I think most of you probably will recognize this situation. You have your AM, FM radio in the kitchen. You have your Wi-Fi router somewhere in the house. You may be having DAB in your car. You got some sort of combination of satellite cable or Freeview. You'll also have your 4G tablets lying around and so on. So you have a box basically for each radio standard. My wife is a minimalist, and she would like to just have one box and not a whole room full of electronics. She also would like it to be wireless. I never quite understood that bit, but she's very keen for things to be wireless. So the idea is we have this single box software-defined radio which replaces everything else, and it's largely future-proof. So if someone invents a new software-defined radio standard, a new radio standard, it can be, an app can be downloaded and so on. So let's start looking at a little bit more detail at the software-defined radio. I first of all like to emphasize that a software-defined radio isn't the card that you buy from Crowd Supply or from Amazon, but it's actually a whole system. So you have the RF parts, which would typically include an antenna and some kind of RF filter, which prevents you being jammed by interfering signals and also stops you interfering with other systems. You also have the radio module itself, which would include some sort of transceiver unit, and then it would either include an ASIC or a field programmable gate array logic system, which provides the connection between the radio and the computer. And these will typically be using USB 2 or 3, or PCIe. And then you have your computer itself and the repertoire of software which you can download off the internet or is supplied by the manufacturer of the equipment. Bear in mind that today's entry-level computers are now multi-core, vector maths geared up machines. So there's been a tremendous leap of progress in the hardware platforms that we have for our computers these days. And of course they connect to good old-fashioned Ethernet, Wi-Fi and ADSL. I could talk about our transceiver. It's a very complicated animal, and I think this is probably true for most of the radio chips used in software-defined radio. So they're highly programmable beasts. We like the term field programmable, which takes on a whole new meaning here, of course. And we're obviously looking for low power consumption, and for today's applications, you don't just have a single channel radio now, but you actually have what's called MIMO, where you would have one, maybe two transmit channels and two receive channels working on different antennas. So the idea of the company I work for is to produce the chips. We then produce the modules. And we're also starting to produce entire systems for our customers now. And what we're relying on is third parties to produce the software, which we then run on those products to generate the different applications. So, for example, we have both USB and PCIe products, and I'm not really into bashing the competitors. They each have their own value. But the main limitation on USB is the amount of traffic you can actually get down the USB cable. So typically for USB 3, you're looking about 30 megasamples per second for MIMO transmit and receive. So that kind of sets the maximum speed for the hardware. PCIe is a bit more relaxed than that. So typically you're looking at something like 60 megasamples per second. For a full MIMO transceiver system. Some of the radios will actually have waveform playback, which I personally find very useful for debugging radios as you're developing them. Our designers have come up with all sorts of fancy cases, so there's not only an evolution of what goes inside the box, but there's also an evolution in the box that they actually come into. So a little bit about our radios. Basically, you can buy them from crowd supply. Other companies will sell them through Amazon. Our crowd supply does give a comparison to some of the competitors, which will help you choose whether our product's the right product for you or whether one of our competitor products is more suitable for your application. We have an open source policy in our company, so the actual hardware is open source. So you can actually read up about the chipsets that are gone into them, and you can then get the data sheets and learn how to program all the different parts and develop a radio at any level of detail which you wish to. We have our own Lime Suite software, which has two roles. It primarily was intended to test the chip as we developed it, but it also produces a C library, which you can then link into with your software. And then you can link into other languages, of course, such as Python. Okay, now for some typical examples. We have a digital television example here, and it's kind of the project that we quite like at Lime because it's a mixture of things. So it has one of our SDR radios in it. It has a Raspberry Pi Zero, and the software was developed by Everest Korsgaard, I think from Denmark. And he has both a transmitter and a receiver for digital television. So within a couple of minutes, you can actually be broadcasting your own digital television stream, subject to the local regulations, of course, wherever you are. Another system that we have, which is actually deployed here, which I believe is working reasonably well, is a GSM base station. I think on each of the data porter cabins here, they have one of these base stations, and it consists of a Raspberry Pi, again one of our SDR modules, and a power supply, and is providing GSM coverage over this site. It's based on open source software developed in Germany by our friends at Osmocom. So it's actually, as I say, an open source, free-to-use system. At the high end of the system, there's also, we have systems with a high processor, so i7 processor, and this is actually being used to generate 4G signals and allows you to do video telephones around the office or in a small local area. And it's also being used in some macro base station developments. So for example, we have a trial system at the University of Surrey in Guildford on top of the 5G IC Centre. And another system is being rolled out, which I think is 20 watts, and is going to be deployed in the Orkney Islands in Scotland. And this is using commercially available software such as Amerisoft and Quartus. And I think the hardware is on the LimeNet project, for those who want to follow up on that. So if you like, it's a combination of second generation professional quality software-defined radios, developments in the microprocessors themselves, and also developments in the open source software and also commercial software that's enabling these radio systems now to be used for entertainment, for surveillance, for mobile communications. And we're gradually making progress to that single box radio. Okay, that concludes my talk. Okay, I'm hold on.
Thanks. Okay. Do we have any questions from the audience? And just if you could try to keep them short in general, and if you have very specific questions, maybe talk with our speaker afterwards.
It's not a question, it's just one of your units is strapped to that pole to your immediate left.
I was wondering, so could you give us an estimate about how long it would take to set up a mobile phone repeater?
A mobile phone repeater, we've done a number of projects with repeater companies, so that can be done fairly quickly. Best way is to contact us and we'll give you a software state for one of the radios, and then you can just develop whatever else you need to make it compliant with regulation.
I thought Osmocom was supporting LTE. Why are you using proprietary software for the LTE projects?
I don't actually know the answer to that one.
If you could raise your hand so I can see it, that would be incredibly helpful if you have any more questions. Okay, I think that is it. Thank you very much. And